Welcome to a new test and teardown video. This time it's something completely different from what I normally present in my videos. This is actually going to be a follow-up video of another video series from another YouTuber called Electronics Old and New. He made a really good 3-part series of this exact same, well, another one, but not exactly this one, but also this Magnecorder PT6V. Mine is serial 277. I think this one is from about 1960 or something like that. And why is it relevant to do a little follow-up video? Because I want to do something completely different with this one. I'm not going to restore this one back to original features and functions. I'm going to modify this one for more current usage. So that means I will remove the record and playback feature. I will of course keep the gain, and the tape speed switch is actually a filter. This I want to remove as well, but reuse the holes for something different. There is a monitor jack. I think I want to change this as well, and the idea is to be able to plug in a guitar pickup here and then use it as a guitar preamp as well. And then I may want to change this switch to microphone input or line input, so I can use the amplifier chain and the transformers and the tubes and all that kind of stuff for microphones, guitar, or line. So that is a little bit interesting. This one came in a pretty bad shape electrically, and also a little bit of, yeah, look at that. There's a nasty dent here, so somebody may tripped in the wire or something like that. Other than that, the paint job is nice and fine. Not a lot of nasty scratches. Yeah, here we got some scratches. The meter is nice and clean and intact. And there's a cool disco sticker logo here. I definitely want to keep that, or maybe even restore that one, because that is so cool. A little bit of sticker nastiness here. By the way, about the previous 3 videos, Electronics Old and New, that channel, I want to put in some links to those videos in my description, so please check them out if you want to know much more about what this is, the schematics, and they explain about signal path filtering and why this and why that, because I don't plan to repeat a lot of all that because it's already said perfectly fine and fantastic. So really, why would we want to repeat all that once again? But I want to show you all the modifications I'm going to do. So let's start a little bit because I already started. The first problem, mains entry. This is a USA plug, and it was just going through an ugly hole here, and then there was this little holder clip like this on the inside. That is just a really not super happy about that as well. And so of course I put in a nice modern IEC connector. It wasn't that difficult to mark. I almost put it in the middle. So I marked this and make this nice hole. And also here originally there was a fuse socket, and those two holes, they are also a modification. So instead of this fuse here, I actually had this funny module mounted like that, using 2 screws and all those wires. So here's another little tube amplifier. That is some other funky, I don't know exactly what this is doing, and I don't have the schematics or anything like that. All I got is this EC92 tube. So this is another extra stage for some funky thing. Of course I wanted to remove this and get back to what I got, because I got a schematic and I want to get it back to a state where I actually have a schematic so I can continue. But I also don't want to use the recorder, because so the playback and the record and all that stuff, the filter, all that is gonna go away. And of course I don't want to have this big ugly connector here. I don't have the mating part as well, and I don't have the tape deck. So this is going away, and I put in a little blank sheet of aluminium here. Then we also got some other funny thing. This bridge input here is also a connector I don't need, so maybe I will remove this and use this hole for something else. We got some other problems with the connectors here. I'm sorry the picture is upside down, but it's just the way it is. So microphone input, that is a female XLR, perfectly fine, all right? Then the recorder, that is a input output directly to the voice coil of the tape deck. So this is input output. And here is its original output from the transformer and some resistors to make this 600 ohms. And look at that, it's also female. So this is quite obvious. Those connectors here, they are this is a really, really special mechanical design, and I don't have those on stock. So I am forced to try and remove this somehow and see if it fits into this hole, because I want to have the output in a male, so I can use standard cables, obviously. And maybe I want to use this input and put it here, input connector here, and then use microphone line input into individual connectors, so it's easier for me to switch between the signals, because I will signal level condition everything, right? And then there is this rectifier, high voltage rectifier. And of course, I'm not using a tube and wasting a lot of power on that, because it has absolutely zero effect on the sound. I just want to remove this and save a lot of energy. So all that is good. It was actually already modified, my unit, using, let's see if I can find them. Yeah, look at that. 2 diodes. So that is, of course, how it was already modified. So, but I will put this into the socket just for nice visual. Then there's this transformer. This is the original mains transformer, and the primary is only for 115 volts. And this is also explained in the, where's my original schematic? I should probably just pop up a picture of the original schematic. And let's zoom into the bottom left corner, and it even says 110 volt AC. That is the primary winding of this transformer. And then I can easily read all the different voltages, filament voltages, and how it's actually making the filament voltages by a variable series resistor and then some capacitors. So it's of course using a DC for the filaments, and that is a good way to avoid a hum. So I kind of want to repeat that, but I cannot use this transformer because I am in Europe, and here we are at 230 to 240 volts. So this transformer got to go. And I found another one. Ta-da! And that one will fit more or less the same holes. Look at that. I think... yeah, you see what I'm saying? Yeah, it even fits. So that means this one is from some other tube stuff. So this one should be able to fit the case. And since it's like that, I will have space for the wires and all that kind of stuff. I don't know if I'm going to use exactly this transformer, because I got a little bit of a challenge because I heard my friend said now he want Phantom power as well for the microphone settings. So I need to create a 48 volt DC as well. Yeah, then there's this selenium rectifier. I don't want to use that as well because there's a lot of forward voltage drop, and I'm using another transformer with a little bit less voltage, and then I was hoping I could do that. So I think I'll just start getting signal through, get some amplification, get some nice sound and all that kind of stuff. And here is the schematic I wanted to show that explain all the changes I want to perform on this unit. So I marked it as easy to see as possible. There's a lot of stuff to cut away and remove, and then some different resistors I want to add. For example, the high voltage supply. I want to, of course, use 2 resistors in the positive and in the negative. This way I decouple the transformer primary system as well as mains actually from my audio system. And it's the same thing with the filaments. The ground for the filaments, I just want to put in a series resistor here as well. And this way my transformer is now not directly connected to my ground and all that, to avoid loops and noise inject that way. And then we got a lot of other problems. Let's zoom in on the primary side. Here you can see a lot of all those switches that's switching between record and playback mode, and it's just one big mess. So I should probably redraw this schematic so it's even easier to see what I want to do here. I want to remove the feedback system, and I want to change this capacitor that decouples the cathode resistor, and this way I can change to the gain I want. And by adding a resistor in series with the capacitor, this is how I want to adjust the gain settings. And I don't want this kind of feedback and all that, because it will affect the different ways that I want to couple my input, because I want to remove the transformer in a guitar mode, and I also need to remove the transformer in line input mode. So I only want to use this transformer for 600 ohm balanced microphone. That is at least my idea in the first idea. And I keep all the rest here in the middle more or less intact. And the output side, there's also problems here. In the original schematic is not balanced output, and I want completely balanced and isolated outputs, because this is just better for a studio environment. So this is why I want to cut all those ground tracks and just make it perfectly isolated and perfectly balanced. And this of course prevents me from having this feedback system. But again, if I remove this capacitor on the last tube to remove all that unneeded gain, then I don't need this feedback system to kill all the gain again. So it's quite simple modifications. And again, you want, when you have a 4 triode amplifier stage, you want as much voltage gain as early as possible, because this is the way you make a better signal to noise ratios. This is just a fundamental way of multi-stage gain systems. Always have as much gain as possible at as early as possible, right? And then you can have, of course, current gain and all that kind of impedance handling and all that. But it's, of course, the voltage gain you want first. So that is my little walkthrough with the schematic. So, of course, I had to remove this record playback switch to get access to clean up all the wires and do all my things in this area here. And also to be able to take out this XLR and swap these. Let's look at this big hefty switch for record and playback. It is very complex. We got 4 individual moving parts here, and we got this 2 times. And it's mechanically locked here for 2 positions. All you have to do is remove this little nut here, and then you can move this dip, 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 and then you can make it move some more or some less. So it's I'm positive I can reuse this switch for the other features I want, but it just don't fit. Once this is in, it's in for good, and then you really need to know exactly what you want. What I want is the ability to be able to mess around and to play around and to get access to stuff. So I think I need a smaller switch, because I mean, you can hardly put it in without damaging or reaching parts. So yeah, this is, by the way, the backside of the input transformer. I already figured out the different color codes for the different wires here, and I want to experiment a little bit with that and do a little bit of impedance measurements and get stuff up and running. So I think I'll just leave that switch out and then just solder the wires in a little bit of flying around here to the input XLR, and then I can play a little bit. This is the backside of the output transformer, and it's ready. I didn't change anything right there. I just removed all the cables for this one. That is the filter switch. We had a lot of wires going everywhere, so now they are out and I can much easier see what I'm doing. I also changed the way that this power supply here is made. So this is the high voltage from the rectifier. It now goes to 2 capacitors in parallel, and then the ground side goes to the ground of those 3 capacitors. And those 3 capacitors, they share a common ground with my signal ground, and there is a good and correctly made signal and power star point right here. Only here it is connected to chassis, so there's no currents flowing in the chassis. So this is a fundamental way to make a good tube amplifier. So that is good. And now all my ripple current is going around here, and it's only DC going in the resistors to this system, and I have resistors in both positive and negative side. So that is just how it was. I had to remove some of those resistors and move it a little bit, so that is better. The other capacitor here is for the filament, and all that is also fine. This is the resistor for the variable voltage for the filaments. Maybe I should try and show that. Here we go. Let's get some light. I'm still working with this. So here is the rectifier bridge for the filament, and here is the AC wires going to the power on bulb. There's a bulb inside of the meter, so this shines up a little bit, and this is running on AC. Funny enough, I changed the bulb to a lower voltage, and here's the DC, and this goes via my resistor to this capacitor, and then it's all my filaments. And I put in a little resistor. It is really dark in here. I put in a little resistor in series with the ground to the other grounds, because there's no current going this way at all. This is just to hold the DC potential of all the filaments at the same potential, so you can measure voltage or whatever you want. It's all that. So I didn't want a 0 ohm resistor, because I didn't want a capacitive coupling through the transformer, through this, and directly into my signal. This is what this resistor is isolating. So yeah, I'm more or less ready to power all this up. I just need to see if I can change those XLR connectors. Look at those really, really funny looking XLR connectors. But I feel they use the same hole for both the female and the male part. So it should be fairly easy to change that, right? I was about to lose my cool to get those damn connectors out. I don't know exactly what to say. So it's a Canon, the brand here, and I've been poking around with electronics for more than 40 years, and I think I have not seen this type of connector before. Exactly this type of mechanical solution. And look, here's the female. Look what I did. I tried to pull out this one, and it's another one. So this is a normal XLR, more or less normal, right? So you put this in here, doodle-doot, and now you can't reach the release. So there is this little thing that is in here. You're supposed to put this in first, but the idea is, I think you get the idea. So when you're there, you push this, chip, chip, and there you have your release. So that means I can replace this with a nice new golden one. But there's this little hole here with a little thread. This is important for this screw, so this one needs to be special. But I will of course try and see if there is a good connection here, but I can feel already there's going to be a problem. If I look through the hole here and look at number 2, then I can see all the metal parts there. In there is just pulled all the way out, so you don't have a good reliable connection, and that is of course needed to have this good and happy working again. So to be able to straighten out this really, really nasty bended front here, I decided to take away the entire front plate and go out to my mechanical workshop. I can get some wood and then hammer it. So I actually found some really nice cores with exactly the right height. So you just put it here, and then everything is nice and straight and easy to work with. So I took the entire front out and nicely cleaned and polished it a little bit. And now we can really see this nasty dent here. And there's no way I can hammer this nice and straight with the meter mounted, because all those vibrations would definitely damage the meter. And this is nice and straight, nice and straight. And here there is a, I don't know if this is visible. Well, this one is also bent. Yeah, here we go. Here you can, now you can see it. Yeah, and I of course also cleaned it on the back, so it's going to be nice and fine. Oh, this table looks like a mess. And then I will try and play a little bit with the meter and see how well that works. I can also clean it a little bit more and make it nice and shiny. let's try and play a little bit with the meter. So this is very close to 1 volt RMS, and it says 0. Look at the speed. It's really nice. The response. So what I have done is, of course, I tested the different. Here we can see what I've done. I just took a little bit of measurements here. So the blue is what I measured, and the red is the optimal values, and it shows it's quite accurate, this meter, more or less over the entire range. So I kind of like that. So now I can put this back in the front plate. So look at all the mess I made. But we got signal through, and we got a lot of gain. Of course, way too much gain. Look at that. And the meter here. This meter can sort of stick, see? And then it goes loose from this stick when you overload it. So I want to prevent that. And this is my input and output on the scope. So this reveals it is phase inverted, and I was very, very careful to follow the schematic and to do all the wires and the phases correctly. So I'm really, really sure that I'm doing it right. And also with the input transformer and all that kind of stuff. So yeah, this thing inverts, and I don't want that. So I will, of course, just flip the output resistors here, because it's completely balanced now. So I have a perfect freedom to do whatever I want. And we can also show what I've done so far with all my little connections here, my little resistor. To handle the input impedance correctly, I of course load the output side of the transformer with a little resistor right there, and that means the transformer ratio is now correct and gives me the correct input impedance with the step ratio. And I have now another attenuator here at the front to make this a microphone level from my signal generator. And then I just measure the input here before my attenuator. And then the output, I can just connect the ground output to ground here. I can do whatever I want here, because it's again completely free, isolated. And then I load this one as well with about 600 ohms. Now I can measure the output of that. I can also measure the bandwidth and all that kind of stuff, and it works from about 30 hertz to 30 kilohertz, minus 3 dB points. So all that is perfectly fine so far. Yeah, and the transformer, the switch, fuse, my little rectifier here, and the series resistor variable for filament voltage is almost up the max, so I'm not dropping that much on the filament, and that means my power usage is only about 13 watts. My anode voltage is also a little bit lower. We are running at 235 volts, and let's see. This is my ripple. Still poking around with this unit. The other switches, it was just way too big. So I'm actually cut it down so I could remove one of the sections. And now I can reuse this. And why do I want to reuse this? Because the click angle matches my front. And I kind of like that. So I also did, this is the input selector. Now it's, instead of record playback, it is now microphone or line input, and I added a little attenuator for line, so that means everything is the same in both modes. And now I want to create the Phantom power system. and I want to put this switch into that position to do that. And here is my jack connector. This was a monitor output, and because this is now balanced, there's no way I can use this as a monitor output. So now it is instrument input, high impedance instrument input, and that goes via shielded cables directly into my first stage amplifier. And all that seems to be working really good. And I flipped the resistors here for the output, and output is now a nice male connector. Yay! So I think this is more or less how this is going to end. My very last little detail is this Phantom power supply that will lift the balanced input for the mic input mode, and this way DC power supply field effect transistor microphones. But there's one little problem, and that is I need some more space to get room for this transformer, because I got no windings on this transformer I can really use for this. And I want this power supply to be completely isolated and regulated and filtered super duper good. So I came up with this really good idea I just would like to share. Since this filter is of no use at all, and it is quite a good volume, and it is in a nice socket, I mean, isn't it just obvious? Just mill away those wells and then pull out the filter and put in a little transformer and regulator and filter and all that kind of stuff, and there you have it, a nice little 48 volt supply. I think this is exactly what I want to do. And I don't want to make this video a lot longer. I think this is already taking a little bit too long time. So I just want to say thank you very much for watching so far. I hope you like this, and please comment if you want more, or if you want less tube amplifier modification, or studio equipment repair, or whatever like that, because I'm doing this all the time as well. So if you want to see more of that, please tell me.